All right, let's get into a story that honestly sounds like something straight out of science fiction. But this isn't a movie. It's happening right now, deep in the world of pure math. And it all revolves around a shape you probably know, and a secret it's been keeping for hundreds of years.
Yeah, you've definitely seen this before. We all have. Probably back in math class, right? It's Pascal's triangle. Super simple pyramid of numbers. And the rule couldn't be easier. You just add the two numbers directly above to get the one below.
And hey, there's a good reason we all know it. This thing has been a total cornerstone of mathematics for over 370 years. It shows up everywhere, in probability, algebra, you name it. It's predictable, it's elegant. You'd think it was, well, complete. But what if it's not?
I mean, what if this super familiar triangle has a shadow self, a hidden counterpart, and antimatter twin that's a perfect mirror image? But get this, it plays by a totally different set of rules.
This is really the heart of our story today, digging into the discovery of Pascal's hidden twin.
The brilliant astronomer Johannes Kepler said it best, "Where there is matter, there is geometry." It's all about this fundamental duality. So if we think of Pascal's triangle as the matter, what in the world does its geometric antimatter look like?
Now here's where it gets really fascinating. Why call them twins at all? Well, on one hand, they're identical in some pretty key ways. They have the same basic triangular shape, right? Their numbers have the same parity, which is just a fancy way of saying their even and odd numbers line up perfectly. And they both create that amazing Sierpinski fractal pattern. But, and this is a huge but, they're also false twins. Why? Because one is built on addition, the other's built on subtraction. One is perfectly symmetrical, and its twin is not.
So, the big question is, what happens when you put these two opposites together? You know, when addition and subtraction literally meet face to face. Well, you get something completely new. And here it is, the fundamental split. You've got the northern hemisphere. That's our good old Pascal's triangle, built by adding. And then you have the southern hemisphere, its antimatter twin, which is built using subtraction. It's such a simple change, but with absolutely profound consequences. And boom, this is the result. This is the Perez hourglass, a bidirectional, self-similar fractal discovered by the mathematician Jean-Claude Perez. You can see it clear as day, our familiar triangle right up top, and its hidden antimatter twin forming a perfect mirror image below it. And together, they create this incredible hourglass shape. But this thing isn't just a pretty picture. It holds what the source material calls 7 exceptional properties, almost like 7 mathematical wonders locked inside its structure.
Now, we don't have time to go through all 7, but let's just unpack 2 of its most mind-blowing superpowers because they really show just how deep this thing goes.
Okay, first up is a property they call perfect balance. And this is just wow. If you look at that southern antimatter half, with all those positive and negative numbers flying around, it doesn't matter how far down you go, every single row adds up to exactly +2. Every single one. But wait, it gets crazier. If you just ignore the ones on the outside edges, all those numbers in the middle of any given row, they always add up to exactly 0. It's this perfect, self-correcting system. Total, unchanging stability.
Now for the second superpower, and this one solves a mystery that's been bugging mathematicians for centuries. You're looking at the Lichtenberg sequence. For 256 years, we've known these numbers, we've known the rule that creates them, but nobody knew where they came from geometrically. They were a sequence without a home.
Well, until now. The Perez hourglass is the missing piece. It is the geometric home for this sequence. Here's how it works. If you take any row in that southern antimatter hemisphere and you add up only the positive numbers on the inside, you generate the Lichtenberg sequence. It's that simple. Let's take a look at one of those rows. The positive numbers inside are 4, 22, and 16. Add them up, what do you get? 42. The exact next number in that 256-year-old mystery sequence. I mean, come on.
Just let that sink in for a second. The solution to a mathematical cold case hidden right there in plain sight for 2.5 centuries was just waiting inside the reflection of a shape we all thought we knew inside and out.
So, solving a huge mystery is one thing, but the Perez hourglass actually does something even bigger. It kind of acts as a bridge. It's like a grand unification theory in miniature. It doesn't just exist next to Pascal's triangle. It actually connects it deeply to other mathematical celebrities like the Fibonacci sequence and the golden ratio. It shows that they might all just be different ways of expressing the same deep underlying fractal geometry.
And this web of connections, it's so profound that it echoes the work of one of the most brilliant and, frankly, mysterious mathematical minds in all of history. The source material actually draws a direct line from the hourglass's properties, all its infinite patterns and harmonics, straight to the legendary work of Srinivasa Ramanujan. It suggests this fractal gives us a whole new geometric way to see the kinds of deep, almost divine patterns that Ramanujan was famous for seeing everywhere.
So, okay, this is all fascinating, but you might be wondering, why does this matter outside of a math classroom? Well, this is where the story takes a huge turn from the purely theoretical to the potentially transformational. I love this quote from the source material. "The sand is no longer falling, it is computing." It perfectly captures this shift in thinking. The hourglass isn't just a static shape anymore, its very structure might be a blueprint for how to compute things.
Researchers are looking at the unique properties of this hourglass, things like its perfect balance and its unique number pairings, and seeing a potential framework for brand new technologies. And we're talking about game changers here. Things like infinite associative memory for AI, blueprints for way more stable quantum computers, and even new types of cryptography that could be unbreakable by quantum computers.
And really, that's the final mind-bending question, isn't it? Could this hidden twin of an ancient triangle, a secret that was kept for nearly 400 years, actually be a map to the next generation of computing? It really feels like the deep past of mathematics could end up writing our future.